Okay, last time we looked at finding the derivative of the natural log of x, and then we used that a few times and used some chain rules. So let's generalize this for any logarithm, any natural log. So if I've got, if we're going to find the derivative of the natural log of any function, so we'll use u to represent any function that's inside of the natural log. So we looked at how to do that. We said we're going to find the derivative of the outer function without changing the inner. So that's 1 over u. And then multiply by the derivative of u. And formally in this case, because we're differentiating with respect to u, that would be du over dx. So that's 1 over the inner function multiplied by the derivative of the inner function. But since mathematicians are lazy, most of the time, instead of writing du over dx, we just write it as u prime. And then simplifying this, that's u prime over u. This is a really important thing to know and to remember and to just internalize, because when it comes time to work backwards from something like this, so if I gave you a function that's in the form of u prime over u, knowing that if that was the derivative, that the original function would have been a natural log. So that's going to come up, but it'll come up later, so don't worry too much about it. So this is something you need to know, something you need to remember, something that's important. This will work for any natural logarithmic function. Okay, now, at the beginning of this unit, I asked you to review some properties of logarithms and exponentials, and this is why. So if I give you a problem like this, where I ask you to differentiate, let's just call it, let's say it's the natural log of the square root of x plus 1 over x plus 5 to the fourth. Notice that I did not put absolute values around these, and that's because the square root of x plus 1 is always going to be positive. That's the principal square root. And x plus 5 to the fourth, anything to the fourth power, will also be positive. So if I asked you to find the derivative of this, you could absolutely use the u prime over u thing. So we could say 1 over that entire fraction and then multiplied by using quotient rule, chain rule, but that gets ugly. A lot of places to make mistakes. So instead, what we'll do is use some properties of logarithms to make this problem a little bit easier. So if I were to expand this expression out, I could write this as the natural log of the square root of x plus 1 minus the natural log of x plus 5 to the fourth. That makes it a lot easier. We don't need quotient rule now. So if we were to use u prime over u, we would just need chain rule. But we can simplify further. What if I rewrote this as x plus 1 to the 1/2, so that these both have exponents? Now there's that rule, I think you called it frog off the log or something in Algebra 2. I don't know if they're still saying frog off the log, but we can take the frog off the log. We can take that exponent out and put it on as a coefficient instead. So g of x equals 1/2 the natural log of x plus 1. Now I do need absolute values because we need to make sure that x plus 1 stays positive. And then 4 times the natural log, same thing here. We do need absolute values. We need to make sure x plus 5 stays positive. Now if we find the derivative, that's going to make this so much easier. So we've got g prime of x, and this becomes 1/2 times, and I'm going to use u prime over u. So in this first one, u is x plus 1. U is the derivative, or u prime is the derivative of x plus 1, so that's 1. So much easier. And then 4 times u prime over u. In this case, u is x plus 5, u prime is 1. If I multiply those out, I've got 1 over 2x plus 2 minus 4 over x plus 5. Okay, now you could go further, you can get a common denominator, but it's not absolutely necessary. Let's say I was asking you to find the critical numbers. So the critical numbers would be, where is this undefined? Where is this equal to 0? Well, undefined would be anywhere the denominator is equal to 0. So we would say that g prime of x is undefined at x equals -1 and at x equals -5. Both of those values would make the denominator denominator 0, which would make the fraction undefined, which would make the derivative undefined. If we find where the derivative is equal to 0, I don't have to find a common denominator. What I can do is just add this 4 over x plus 5 to the other side. And then I can use cross multiplication, or however you want to think about it, where I can multiply these and I can multiply those and solve it from there. So I would have 4 times 2x plus 2 equals 1 times x plus 5. And now I've just got a linear equation to solve. 8x plus 8 equals x plus 5. So I get 7x equals -3. And there's another critical number then, -3/7. Okay, just wanted to show you how those properties of logarithms can really help make things a lot easier. So keep that in mind, make life easy on yourself, and have fun.